Hi, so this is the last video for Unit 3, yay. So we are going to be learning about what a function means and what is a function and what is not a function today. Okay, so I'm going to show you the filled out notes and then make sure you fill them out on your own on this slide. Okay, so I just want to go over what a definition of a function is. So a function is a relation in which every input, x, has exactly one output, y. So essentially that means none of the x's can repeat. Some characteristics that you can be aware of is the vertical line test. Many of you have heard about that, and it can be used to determine if a graph is a function, because if the vertical line touches the graph more than once, that means one of the x's is repeating because they're on top of each other. That means your graph is not a function. Here are some examples of a function. You can see here that none of my x's are repeating. Is another example. Each input only has one arrow to it. Even though the 6 has 2 arrows going to it, it's an output, a y value. It can have more than one x, but an x cannot have more than one y. And these are some non-examples right here. So as you can see here, my 2 is repeating. So that means it's not a function. And you can see here, I can draw a vertical line down it and it will hit this graph more than once. So it's not a function. All right, going to what's actually in this slide. There we go. All right, so we have right here just define whether a relation is a function or not. So remember, functions cannot have an x that repeats. So we're looking at a graph first. So is this a function or not a function? Well, it's not a function because look here, the dots are right on top of each other. So my coordinate numbers would be 4, 4, 4, 3, and 4, 2. That means the 4 is repeating, so therefore it is not a function. Also, I could draw a vertical line and it goes through all 3 points. So the input of 4 has 3 different outputs. Hence, it's not a function. All right, let's look here at an input-output table. So remember, the arrow coming from the input to the output tells you which is the x and which one goes with the y. So I have -1 to 1, so that's one pair. I have 2 to 4. I have 3 to 4, and I have 5 to 6. Do any of the inputs have more than one arrow? No. Even though this 4 has 2 arrows going to it, it's an output. It can have more than one arrow. So this is a function because every input has exactly one output. Now let's do a table. So here I have a list of x's and a list of y's. So again, remember what can't repeat? X's. So let's look at the x's. Oh, I have 2 1's here. I have 1, 0 and 1, 1. So this is not a function because the input of 1 has 2 different outputs. So remember, x's can't repeat. Okay, so that will cover these 2 slides here and these 2 slides here. Okay, so your job, if I can get it, it's being very slow. There we go. So your job is to match each of the graphs, the tables, the equations, the input-output tables into the right column. So you can just move these around, okay? Easily move. So move them and order them so they're either on the function side or the not function side, okay? That's all you got to do. You don't have to do anything else with it. Just put them on the right side of the page, okay? So remember, a function is has exactly one output for every input. So it means x's can't repeat. And remember, we can look at the vertical line test for graphs. The x's can't repeat for like a table or a set of ordered pairs or the input-output table. Equations, remember equations can have like the f of x. It can have also y. So it doesn't mean anything if it's f of x or if it's y. It still is the same type of thing. All right, so you're just going to drag these into the right page and make sure you fill out your notes on the previous 2 pages, and I will see you in the next unit. Bye.